Hey guys, welcome to the Unit 2 test review. We are going to start out naming if these graphs are functions. So number 1, I'm going to draw my first vertical line. And since my vertical line hits my graph in two different places, we know that this is not a function. Number 2, since I can draw all of these vertical lines, and none of them hit my graph more than one time, we know that this is a function because it passes the vertical line test. This one, number 3, is a circle. It hits my vertical line twice, meaning that it immediately fails the vertical line test, so it is not a function. And for this one, we're going to check to see if this is a function, meaning that every input has to have only one output. So 2 has only one, 4 only goes to one thing, 6 only goes to one thing, 8 only to one thing, and 10 only to one thing. Since each input only goes to one output, that means that this is a function. For the next one, we're going to check to see if I have any vertical lines that hit more than one point. Immediately, when I draw a vertical line on the y-axis, I see that it hits more than one point, therefore it is not a function. The color of student I's and their last name. So your I would be your X and last name would be a Y. So in this case, if we look around the room and we were to pick out some people, there might be multiple people with brown eyes and multiple people with blue eyes and multiple people with green eyes. Since the eye color is duplicated and everybody has a different last name, this would not be a function. And last but not least, we have this set of numbers. We need to make sure that I have no repeated x values. So I start off with a 0, a -3, I have another -3, and another -3, and a 0. So first off, we see that I have repeated x values, but let's see if my y values are going to be different as well. So I have -3 and 3, -3 and 3, and then we have a 0. So since in this group of -3 as x values, and we have different y values, we know that this is going to be not a function. It is okay if x values repeat and go to the same thing, but as soon as it goes to something different, we know that it will not be a function. Moving on to number 2. What is f of 1? Remember that 1 is an x value, so we'll go look for 1 in my x box and then find my y value, or my function value, which is 3. Next, I'm going to list off my domain. My domain is the set of all x values, going from least to greatest. And range is my y values, and again, we will put curly braces around them and list them from least to greatest. Find the domain and range. My domain here is the set of all my x values, or my input values, which is going to be 2, 4, 6, 8, and 10. My range is going to be my output values, also known as my y values. And we'll want to put these in numerical order from least to greatest, which is also going to be 2, 4, 6, 8, and 10. Remember, we use curly braces when we have a list of values. Now moving on to number 4. Find f of 6. 6 is an x value, so I go to 6 on my x-axis and then find my f graph, which is right here, meaning that my y value is going to be at 9. Now I need to find g of 2. 2 here is an x value. I go to 2 on my x-axis, then to my g graph, which is going to be down. That gives me -8. Now I need to find where f of x equals 8. Remember, when it's equal to a number, that is a y value. So I go up to 8 on the y-axis, then over to my f graph, which gives me 4. Now I need to find f of 0 plus g of 2. F of 0 is going to be 0 on the x-axis, then up to my f graph, which gives me 6. Plus g of 2, I go to 2 on my x-axis, then down to my g graph, which is -8. 6 plus -8 is -2. And last but not least, I need to find where f of x equals g of x. That is my point of intersection. This is where my graphs cross, and that is going to be at -4, 4. And remember, every time we ask you for a point of intersection, you must give an ordered pair. Using the graph below, complete the following. So first, it wants me to complete the table to the right. So I have 1 and 38, 2 and 50, 3 and 62, 4 and 74, 5 and 86. I got all of these numbers from the corresponding graph for this problem. Next, it wants my domain, which is my input values. I always list them from least to greatest, which is 1, 2, 3, 4, and 5. Next, it wants my range, which is my output values. I'll put these in curly braces again, which is 38, 50, 62, 74, and 86. Slope and y-intercepts graph the following functions. Remember, for these problems, for you to be able to graph them, it has to be in slope-intercept form, also known as the form that is solved for y. This form gives us my slope, which is -3, and my y-intercept, which is 4. So I start at 4, I go down 3 over 1, down 3 over 1, down 3 over 1. And when I connect it, I get this nice straight line. Now we need to do number 7. If you'll notice, number 7 is not solved for y. So I'm going to come over here and solve it for y so that I know how to graph it. First thing I need to do is subtract 4x from both sides. So I get 8y equals -4x plus 16. Now I need to divide by 8, and I get y equals -1/2 x plus 2. So I know that my slope is -1/2 and my y-intercept is 2. So I go down 1 over 2, down 1 over 2, so on and so forth until I get all of my points plotted on my graph, and then I will connect them together. That changed on me. Sorry about that. That's going to bug me if I don't change it back. There we go. Moving on, we need to find the slope, y-intercept, and equation of the line. So to do this, I'll just write m equals and b equals. First, we'll find my slope by finding two pretty points on my graph, and then I will count rise over run. In this case, I rise 5 and then run 2. So my slope will be 5 over 2, or 5 halves. My y-intercept is going to be where my graph crosses the y-axis, and this is going to be at -5. Now I need to plug it into the equation of a line, which is y equals mx plus b. I only plug in m and b, and that will give me 5 halves x minus 5 for my final answer. And last but not least, number 9. First, we need to find the domain. My domain is my set of x values from start to finish. So I start at -1, 2, 3, 4, 5, 6. And I end at +1, 2, 3, 4, 5, 6. Since I have solid dots, that means that I will put brackets around my domain. That means that both of my endpoints are included. Now I need to find my range. That's going to be my y values. My smallest y value is 0, and it goes up to 1, 2, 3, 4, 5, 6. And since I have solid points at both of these, I am going to use brackets again. Now I need to identify my intervals of increase and decrease. An interval of increase is when I have a positive slope, which is highlighted in the yellow, and my intervals of decrease is when I have a negative slope, which is now highlighted in the pink. Remember that we measure increase and decrease using my x values. So I like to put a quick guide of what I'm doing on here every time it breaks. So I'm breaking at -6, -3, 0, 3, and 6. Between -6 and -3, I'm decreasing. Between 3 and 0, I'm increasing. Between 0 and 3, I am decreasing. And between 3 and 6, I am increasing. So my first interval of increase is -3 to 0. My next interval of increase is from 3 to 6. And remember, every time I talk about an interval of increase or decrease, it has to be in parentheses. My first interval of decrease is from -6 to -3, and my next one is from 0 to 3. If this helps you to make these markers and label where it's going up and going down, then do it. Every little thing helps. Now I need to find my slope from 0 to 3. So 0 and 3 are x values. I need to go up to my y-axis to find my y value, up to my graph to find my y value. Now I can count my slope. I fall 1, 2, 3, 4, 5, 6, and run 3. When I simplify that, that'll give me -2. Now we need to find our maximums and minimums. Remember that your maximum and minimum values are y values. So my maximum value here is 6, and my minimum value here is 0. Now I need to find x-intercepts. That's when my graph crosses the x-axis. and it crosses the x-axis at 3, 0. And y-intercept is where I cross the y-axis. It crosses the y-axis at 0, 6. There you go. That is all. If you have any questions, feel free to email me or get on one of my live sessions. Have a great day.